What is IHD? 4A? Okay. Is everyone getting the answer 4? Okay. What do you mean by 4? What should be 4? There should be 4 double bonds. It should be 4 ring, one ring, 3 double bonds. Yes or no? Okay. Any possibilities there? Okay. Now I want you people to try. Uh, with respect to IR, what do you think it should be? IR. What do you think IR can give you? Now, what I was going to tell you is when you have these two values, okay, remember when you have two values at 750 and 690, it is always related to mono substituted benzene. So, if you could remember this, okay, mono substituted benzene, or when it is ortho substitution, you will get a peak at around 774, 735. Meta substituted, there will be one value. Para substituted, also one value. But when it is mono substituted, you will get two values. Okay, that means it is mono substituted. Now, what is that mono substituted? Okay, we'll come back to that later. But can you give me an idea what else could you get from IR? Now I told you certain values, 1600, 1470, fine. You may not be able to remember what these values are. Come to NMR. Hmm? Now, from NMR, do you think any significant group that you can get looking at NMR? I've told you certain values that you should look for. When you always remember when you have a molecular formula like C6 or more than 6, okay, more than 6 carbons are there. There is a strong possibility of benzene ring. And for benzene ring, which NMR values you are going to look at? 7 to 8 ppm, whether there is any value at 7 to 8 ppm. So is there any value at 7 to 8 ppm? Our molecular formula is C9H12. That means it is more than 6 carbon atoms. So there is a strong possibility of a benzene ring, right? And now to confirm that possibility, you should look at the NMR. See the peak 7.5 is there. So what should be present in our compound? One benzene ring is definitely there, right? Now, if one benzene ring is there, how many carbons are utilized in the benzene ring? 6 carbons. So, how many carbons are left now? 3 carbons are left. Yes or no? Okay, it's a mono substituted benzene, means one of the hydrogen is substituted. So, how many hydrogens are left here? One, 2, 3, 4, 5. So, subtract 5 hydrogens from this 12. So, how many hydrogens are left now? 7. Now you just have to arrange these 3 carbon atoms and 7 hydrogen atoms. Are you understanding this? Hello? Are you students? Now can you try to tell me what could be, how are you going to arrange these 3 carbons and 7 hydrogens? Can you think of it? Hmm? See, if there are 3 signals in NMR, that means it has 3 types of protons. Okay, one is your benzene proton, so that is done, and 2 more are left, but there are 3 carbons. That means 2 types of protons should be equivalent. Okay, now you people tell me, think of it, what it should be. It's a doublet and it's a multiplet. If it's a doublet, what should be the neighboring proton? One. Ha, it's a doublet, no? So your neighboring proton should be CH. So one of the group is CH. So that is done. Now two more carbons are left, and 6 hydrogens are left. How will you arrange this now? Hmm? See, yes, very good. CH3, CH3. So that means this group should be like this, right? So this CH3, because of this proton, it will have a doublet, and this CH, because of 6 protons attached to it, it will have a multiplet. So just put it over here. This is your structure. Got it? So these are your benzene protons at 7.5 ppm. Okay, it's a multiplet for benzene. CH, this will be multiplet because there are 6 hydrogens attached to it, no? and these two are equivalent proton, hence you are getting only one signal because they are equivalent proton. And which is the signal at 1.2 ppm, which is a doublet. Why it is a doublet? Because of this proton. Have you all understood this? Hmm? How did you come to know that it is mono substituted? Because you have two peaks at 690 and 750, because there is a possibility of this type of structure also. Like this is also possible. It matches the molecular formula, right? But then why it is not possible? Why this is not possible? If you look at this, you will get one signal for benzene, you will get second signal for CH2, you will get third signal for this CH3, you will get fourth signal for this CH3. So there are four types of protons, so you should get four signals, but in the data given you are getting only three signals. So if you think that you can write one more structure, then always match it with the NMR and check which is the most probable structure. So which structure is matching? This first one is matching. Have you all understood this type? This, hello students? This is the one. Next question. So you have the molecular formula and it's a very small formula. Okay, so you can get the structure also very quickly. Determine IHD. Come on, quickly tell me what is the IHD of this molecule. Okay, 2C plus 2 minus 0. Okay. UV transparent about 200. That means it is not giving any UV signal. Okay. Now in NMR, what is written is tau, and most of the NMR signals, what we are always calculating it is in terms of delta. How is delta related to tau? How is delta related to tau? It is, now if you want to calculate delta over here, delta is 10 minus tau. So whatever signals are there in tau, you have to first convert it into delta. Okay, so our first NMR signal, which is 5.42. So just subtract it from this. Come on, go on subtracting each signal from 10. Why are we doing this? Because we have learned our values with respect to delta, and the signal given here is in terms of tau. That is why we are finding it out. Okay. Mm, okay, do it now. Here is also given. I'll write one or two values. Okay, 13410. We'll finish finding the answers. What is the answer for the first one? Come on, this is simple subtraction. हाँ, किती है ये? 4.58. Okay, next is hmm, structure. Now I had forgotten to write, sorry, the IR values. So IR is given over here. So can anyone try? Come on, I want you people to try. Now see, I will also write here this 4. This is singlet, this is triplet, this is sextate, and this is triplet again. हाँ, आता ठीक है. Tell me, what is it? Is it going to have any neighbor? From this we find out what type of neighbor should be present. If it is having a singlet, no neighbor. That means no proton. Okay. If it is having a triplet, how many protons should be there? Neighboring protons? Yes, very good. If it is a sectate, how many neighboring protons should be there? 6 minus 1 means 5. So there should be 5, approximately 5 protons. If it is a triplet, how many neighboring protons should be there? 2, no? CH2. Now see, you have got two groups confirmed, CH2, CH2. 5 protons means, can one carbon have 5 protons? No. So it should be somewhere in between of two different protons, okay? And there is one singlet, and there is this peak in IR. Can anyone try to write the structure? Come on, I'll give you few minutes. 3410, what do you think is 3410 in IR? Yes, now you know there is a OH also. Okay, so functional group here is OH. Come on now, combine all these values, combine all the data, and try to write the structures. Now it's a very, very small molecule, C3H8O. So you don't have to think much. You can simply write the three carbons in single line. Hmm. There is a O. Now you just have to arrange that O somewhere. How are you going to do this, students? And you know, two of the groups are CH2. So you can simply write two groups as CH2. Done. Now can you tell me what should it be? See, there are four signals in NMR. That means there are four types of protons. Okay, CH2, CH2 is done. So how many carbons are done? Two carbons are done. Four hydrogens are done. So one carbon is left. Hmm? Out of H8, four carbons are done. So four carbons are still left. Four hydrogens are still left. Out of the four hydrogens, one hydrogen goes with the H. So three hydrogens are left. So just put this three hydrogens somewhere. Where are you going to put these three hydrogens? One carbon is left and three hydrogens are left. So definitely this group will be CH3. So you will have this CH. So place this group CH3 over here. Okay. And now only one OH is left. And I'll place this OH over here. So you have got your structure. Now match it with the NMR. So this will be a triplet. This will also be a triplet because of this CH2, and this CH2 has five hydrogens, so 5 plus 1, this will give you a septate, and this will be giving you a singlet. So it is matching with our NMR, and OH is in IR, it is giving you a peak at 3410. So that is also done. And since there is no double bond, since IHD is 0, there is no double bond. So C double bond O possibility is ruled out, because sometimes when oxygen is there, the first thing that comes to our mind is either it could be C double bond O or it could be OH. Yes or no? Are you people there? Now I want you people to try this, please. And it's a very small data is given, very interesting, and think of it now. The formula, what did I tell you? If you have a carbon something like 6 or more than 6, it is most of the time benzene ring. So come on, try. Try it. I'm getting a call. You just try meanwhile. C6H6 NPR, no? So 6 hydrogens, if when I told you that if it is 6 or more than 6, if it is 6 or more than 6, what is the possibility? There is a possibility of a benzene ring. And to confirm this possibility, look at the NMR peaks. If you are having somewhere something around 7, it is always a benzene ring. So because we are having an NMR peak at this, it will be a benzene ring, right? Come on, now rest of the structure you people try. Carbons are utilized in the benzene ring. So no carbon is left, but hydrogen is left. So where should we put that hydrogen? And look at this value. Around 750, you are just getting one peak. One peak means it should be, is it mono substituted or di substituted? I'll, I'll show you the IR values here. Look at this. See this IR values over here. So if it was mono substituted, you could have got two peaks. But now you're getting just one peak, and that is 750. Where it should be? 750, peak at 750 means, what is it? 1 2 di substituted, ortho substituted. You can say 1 3 di substituted also, but okay, what should it be? 1 3 di substituted or 1 2 di substituted? Now you can write any of the structure because other details are not given. Okay, fine. So what is the answer? What do you think the structure would look like? If it is this, that means something is on this carbon, something is on this carbon. So what do you think the structure could look like? Now you just have to arrange. You have to arrange out of 6 carbons, all the 6 carbons come in the benzene ring. Out of the 6 hydrogens, 4 hydrogens are in the benzene ring. So 2 more hydrogens are left, 1 nitrogen is left, 1 Br is left. Okay, it's very clear what groups could be present over here. What should be your structure now? बोला स्ट्रक्चर स्ट्रक्चर बोला नुसते गप्पापासून नका तिथे. What is the structure? Arrange NH2 and Br. Yes, very good. Done. And now match the NMR signals. Match the NMR signals. 627 is your benzene ring and 3.6 is your NH2 peak, which is a singlet. I hope you are understanding this. Disturbances मध्ये मध्ये सगळं चालू आहे. आता हे ट्राय करा चला. ये किया था क्या हम लोगों ने? नहीं ना? तुम लोगों को तो सब कुछ सेम ही लग रहा होगा. किया नाही किया क्या फरक पडत आहे? हां, तर काहीतरी मला सांगा याच्यामध्ये आन्सर. कम ऑन. I told you more than 6 is always a benzene ring. So check whether benzene ring should be present or not here. Is benzene ring present here? Hmm? Yes. So benzene ring. So one group is confirmed. How many carbons are in the benzene ring? 6 carbon. So how many carbons are left now? 3 carbons. Okay. Now see, IR only one value is given 1742. What it should be? Hmm? Anyone? What it could be? C double bond O. Yes. So out of the C three carbons, one carbon is done. Now only two carbons are left. Right? See how you should go with the structure. Hmm? Now look at the PMR. Come to PMR. See now in the PMR, such PMR values are very easy, where they give you directly 3H and 2H. So what do you think it should be? Hmm. One is CH3 and one is CH2. Now you have to arrange it and see they are singlet. Huh? They are singlet. This CH2 is a singlet. That means there is no neighbor around it. This also is a singlet. There should be no neighbor around it. Now you know the groups. One is CH2, one is CH3 and one is CO. How are we going to arrange it? How are we going to arrange it? What is it? You just have to arrange it. So one benzene ring is there, C double bond is there, CH2 is there, CH3 is there. Just arrange them. How will you arrange it? Now let's try. Come on, anyone, come on, tell me what are the different possibilities of this structure. What should I write here now? C O. This is what you said. Hello. Acha, what did you say? C double bond to CH2. ऐसे CH3. लेकिन CH2 भी है ना, उसको किधर डालने का फिर? ये बच गया ना. Or if you write whenever you write a structure na match with the molecular formula and NMR. Is it matching with the molecular formula? This is 6, 7, 8. So this is wrong. Is this structure? काय बोलते? ते तुम्ही सांगा ना मला. हा मॉलिक्युलर फॉर्म्युला राईट आहे पण स्ट्रक्चर NMR शी मॅच करा. Matching NMR. Suppose I have this signal, I will get a triplet. And for this I will get a quartet. Are you getting a triplet quartet combination here? No, it's singlet. So this is also not possible. That means you have to rearrange CH2, CH3. Any other rearrangement that is possible? Hmm. Yes, very good. So now you will get a singlet with 3H. This also will have a singlet with 3H. Then you have the IR value and this is your 7 signal at 7.2 signal multiplet. Got it? Okay. So whenever you write a structure, you may get different structures, but you have to first match it with the molecular formula and you match it with the NMR. Okay. Once you know the theory, this becomes very easy. Now last one. Okay, then we will stop. Come on, I want you people to tell me this. Please. Come on. C6H14O and see there are so many signals. Now I told you 6 and 6 above 6 it should be benzene ring. Confirm with the NMR whether there is a peak at 7. Is there any NMR peak at 7? 1.5 है 1.6 है point 0.8 है 1 है. Is there any peak at 7? No, that means there should. हाँ, तो is there a benzene ring in this? No. No, so now you have to be very careful. There is no benzene ring, that means 6 carbons you have to arrange, right? And there is a O. Okay, and there is O and the peak is at 3600. So what it should be? OH, yes. So one group you have got, it is a OH. So that is done. Now you have to arrange the carbons. Now look at this. It's see here it is given 6H, 3H, 4H, 1H. क्या क्या हो सकता है? Can one carbon have 6 hydrogens? Then why 6 hydrogens are given? Can one carbon have 4 hydrogens in a molecule? No, it's not methane, no. So what is this? Now you look at this triplet, triplet, singlet, quartet. What do you think? Let's start with zero point 0.8 ppm. Zero point 0.8 ppm, triplet. So what should be your neighboring proton? If it's a triplet, neighboring should be CH2. Very good. Then you have 1.0 singlet. Should it have any neighboring proton? No, no neighboring proton. Okay. Then you have a quartet at 1.5. What is it? Neighboring proton will be? Very good. So see now what you are coming to, you have one group as CH2, one group as CH3. Whenever you have a triplet quartet combination, it is always CH2, CH3. And then last one is singlet. There is a singlet. That means there also there is no neighboring proton, no? No neighboring proton. Okay. Now if you have one group CH3, CH2, this is confirmed. Then what does this 6 hydrogens indicate? What should it be? There are 6 hydrogens and there are 4 hydrogens. That means this is not on single carbon atom. That means there should be 2 equivalent CH3 groups. It should be 2 equivalent CH2 groups. That means these two groups should be attached like this. And there is one OH. Okay. And now there is one group with 3H. That means there is one more CH3 group. But it is a singlet. That means there is no neighboring proton. So just put it over here. Done. This is your structure. Are you getting this? See how 6H and 4H are done. So this CH3 is the peak at 6H, 0.8 ppm triplet. Okay, this is your 0.8 ppm triplet because of CH2 group. Because they are equivalent protons, both of them are having a single peak. So this is A. B is this, because they are also equivalent protons. So when you are getting a NMR signal, this will the maximum peak will be of CH3. Then you will have a CH2 peak, okay, which will be integrated to 4 protons. 4 protons. Here it will be integrated to 6 protons. This way. This will be a singlet because there is no neighboring proton, and this will be also a singlet because there is no neighboring proton. It's attached to O. This is how it is done.